All right, so on Friday, I had already drawn the diagram for this, so we'll just quickly draw it again. Our 15 meters at 15 degrees north of east. So I always look to the second direction as my reference line. So I'm going to draw a line that is due east. Then I'm going to draw another line that is approximately 15 degrees north of that. That is 15 meters long. Okay, this will be the y component of that line. This will be the x component of that line. The next vector is 13 meters long at 5 degrees west of north. So I need to draw a reference line that is due north. Okay, and then go 5 degrees west of that. Okay, again, it doesn't matter if it's exact, as long as it's somewhat to scale, the diagram will work. 5 degrees, 13 meters. Okay, so those are my two initial vectors. They're drawn tail to head. I've identified the x and y components, okay, which is like the first 3 steps of the steps we went over last week. Right? My next step is that I need to draw my resultant, which always goes from beginning to end. So it would look like that. And then I need to draw its triangle. I could draw it across my current diagram, but that's going to get really crowded and busy. So I prefer to draw it outside of the diagram over here. Okay, just because that kind of looks a little less messy. All right, so this will be the y component, this will be the x component, and this will be my resultant or total displacement, okay, for this question. And then, of course, it will also have a vector, which will go right in there. Is that ringing a bell from last week? Okay. So here's what we've got to do. We have got to calculate, okay, all of our x and y components from our first 2 vectors. So black x, okay, is the adjacent side to the 15-degree angle. So I'll calculate black x using the cos of 15 degrees times the hypotenuse, 15. All right, so we're going to have cos of 15 times 15. And that's going to be 14.4888. 739 meters, and that's pointing east, so I'm just going to write east off of that so that I remember. All right, black y is the opposite side, so I'm going to go sine of 15 times 15 meters. So this would be pretty small. All right, so that's going to be 3.8822 meters, and that is going to be north. Questions so far? All right, now I've got to do the same things with my second vector, with the 13-meter vector, so that's the red triangle. Okay, so red y or red x, we'll do red x first as we're doing them in the same order. Red x on that diagram is the opposite side, so I'm going to use sine to calculate it. The sine of 5 degrees times the hypotenuse, which is 13 meters. All right, so it's very small, 1.133. Zero 2 4 6 5 6 meters. And which way is that one pointing? Yeah, that's the x. Which way is it pointing, east or west? West. Okay, because I mean, if I look at my triangle here, right, I've drawn that one going back this way. This was west of north, so the x component has to be west. Right, you can always tell by the directions you were given initially that your x component will be west, your y component will be north. Everyone okay with that? Okay, so now I've got to find the y component. It's the adjacent side. So cos of 5 degrees times 13, so it'll be quite large by comparison. All right, so 12.9505. Oh, sorry, 3108. meters, and that'll be north. All right, so now I have all the x's and all the y's. What do I do with them next? Jamie, what do I do with them? Right, I add the x's together, I add the y's together, and that will give me my resultant x and resultant y. Okay, so I'm going to add the two x's together and get this. One of them is east, one of them is west, so I'm adding a negative or I'm subtracting, whichever makes more sense to you. It doesn't matter to me. Okay, so I'm going to take those and find out what green x is. All right, so green x will be 14.488 minus our 1.133 there. Okay, so we'll figure out what that is. Okay, so 14.4888. All right, so we've got 13.355, okay, 356. Okay, meters, and that's going to be east. Okay, and then I've got to find the y. All right, both y's are north, so I'm going to add them together. Okay, I don't have to worry about one of them being negative. So we'll have our 3.88225677 plus 12.9505 3108. Okay, so we've got 16.8328 meters, and that's north. Okay, so now I've got the two sides of my resultants triangle. Can I find my resultants? Okay, Peter, what am I going to do to get that? Right, I'm going to use Pythagorean Theorem to get D. All right, so D will equal the square root of the 13 squared, okay, plus 16 squared, obviously with all the decimals in it. I'm just kind of shortening it there. Okay, so we'll have the square root of 13.35586.273 squared plus our answer from the last one squared. All right, so our overall displacement's 21 point, and I think we have two significant figures here, so it's just going to be 21 meters. And then our angle, okay, and we've got to calculate that, so we'll use trigonometry. We can use any trig function we want because we have all three sides now, right? But I'm going to go with tan because that's my favorite. Okay, so tan to the minus 1, that's my opposite side, the 13 over the 16, so 13.35586.3 divided by 16.83278. All right, so I'm getting an angle there of 38 degrees. I've only got two significant figures, so I'll leave it at that. All right, so in the end here, my final answer would be that the total displacement is 21 meters at 38 degrees. Which direction is that? East of north. Right. Okay, I could also have the complementary angle, which would be 52 degrees north of east if I drew the triangle the other way. Okay, questions on how that one worked? Okay, I want you to try number 3. Number 3 is exactly like the vector addition question I put on last semester's unit exam. It had one line that was straight along one of the axes, so it didn't have any like x's and y's, and one that was then angled after that. All right, so give that one a try. Okay, using the same steps that we used here. Okay, so our first step is we have to draw the diagram. Right? Our first vector is that the bear or the biologist runs 300 meters south. Right? So that's just a line that's straight down. Okay? It doesn't have a triangle. It's just straight down. It only has a y component, and that y component is 300 meters. Okay, and then we've got the other vector, which is 550 meters at 75 degrees north of east. Okay, so here's east. Well, sure, I'll draw it in a different color here. All right, so there's east, and I'm going to go 75 degrees north of that. So almost straight back up, because 90 would be straight back up. Okay, so you suppose that 550 will get further north than I started? I would say so. It's 250 meters longer than this line is. Okay, so chances are it is going to go further up than this did. So I'm just going to move this down so I have enough room to do that. Okay, so 75 degrees, something like this. All right, so there's my 75 degrees. This line is 550 meters in length. Here's its y component. Here's its x component. That means my overall displacement is this blue line. Okay, so here's theta, here's y, here's x. Okay, that's going to be my overall displacement. So the blue triangle is my resultant. Okay, I've got to figure out its sides by figuring out what its x and y components are. All right, I'll give you a few more minutes. Hopefully that diagram's going to get you on the right track there. Okay. This is, guys, where scale of your diagram is important, right? If you don't get the diagram right, it'll seem like your math is lying to you. Even though the math is right, it's the diagram that's lying. Okay. Here. Okay, so we have to find our x and y components for the green triangle. We don't really need to find them for the black line because the x component on that one is 0 meters. It doesn't go east or west, okay? So we don't have an x component there. And the y component is 300 meters south, all right? And then for our green triangle, okay, x is going to be the cos of 75 because it's the adjacent side times 550 meters. So cos of 75 times 550. Whoop. That gives us 142.350. Okay, and guys, just for the sake of expediency, I am going to round off my numbers here just so I don't have to remember them all. Okay, you shouldn't do that, but I'm going to do it just for quickness sake. Okay, all right, so that's going to be east, and then we're going to have the y component, which will be the sine of 75, so the larger of the two sides, times 550. Okay, so sine 75, 550. All right, 531.259 meters north. Okay, so if I'm going to find out what blue y is and blue x is, okay, well, blue x is obviously the same as green x, right? There's no x component for the black line. The only distance east or west it went was this one, right? So green x and blue x are identical, so that's easy. I don't have to do any adding or subtracting there. It's just 142.35. Okay, and then for my y, I'm going to subtract 531 minus 300 to get the distance north that I have left. Okay, so I'll take my 531 minus 300, okay, it's going to be 231.259. Meters, okay? Then I can do Pythagorean Theorem to get what d is. So I'll take the square root of that answer squared plus 142.35 squared. All right, so our overall displacement's 271 meters. We only have two significant figures here. Okay, they actually have a mistake here. This has how many? It says 3. Okay, so they made a mistake here. All right, but we're going to have 202.7 actually times 10 to the 2 will be our d. Meters, because we got to put it in scientific notation, and then we'll find theta. Okay, theta will be tan to the minus 1 of our opposite side, which was our 142.35 divided by our 231.259. All right, so I'm getting 31.6, which is 32 degrees, okay, which is the complementary angle to what they have. So at 32 degrees, and that is going to be which direction? This way is north, and that way is east, so this is going to be east of north, right? All right, there's my final answer. Okay, I could have also had 58 degrees north of east had I drawn the triangle this way. Okay, now at this point, Mr. Dickey and I usually point out that there's another way to draw these diagrams. If you're finding that these diagrams are really busy, hard to get your information off of, things like that, you can use what we call the separate triangle method. Okay, and it's exactly like it sounds. You just don't draw the vectors tail to head. You draw the triangles separately. Okay, so for this one, that would mean basically only one triangle. So you'd have this, and then you'd go x equals 0, y equals 300 meters south. And then for the other one, you'd go like this, 550, 75 degrees, okay, this is y, this is x, and you'd figure them out. Draw them separately, okay? Then do, the rest of the math is the same. You still add the x's and add the y's together, and you build your final triangle instead of seeing it right off the bat, okay? So I don't use this method because I'm one of those people who needs to see the end result while I'm working, okay? But if you're finding that that's too much, and that you'd rather kind of go with it kind of piecemeal and build the final triangle as you go, that's also fine, okay, because it'll work out mathematically to the same thing. Okay, I'll take my y's, add them together, and I'll get, you know, that small y that we got, and then I'll take my x, and it was like this, and then I'll go, okay, here's my final triangle. It looks the same as the final triangle I drew up there. It's just I arrive at it slightly differently. Okay, whichever way works better for you is fine with me, because mathematically, again, they're identical. Okay, questions on that? All right. So we're going to spend a little time practicing this stuff, because the only way to get better at it and quicker at it, more importantly, okay, is to practice doing it. Getting used to drawing those diagrams is a big part of that. So in your workbook, okay, there's some of these kind of practice questions. They start off really easy, like they're all collinear, and then they're perpendicular, just kind of warm you up. Okay. Okay, so it starts on the bottom of page 7 in the workbook. Okay, the answers are here in bold and brackets, so you can check them as you go. Okay, like I say, it starts out really easy. You got some collinear ones in question number 1. Okay, a bit of perpendicular to end question 1. Okay, and then, well, sorry, to end question 1, you get a couple more here, and then it'll start getting into find the x and y components. And then by the time you get to question number 3, like 3E and 3F, those are like what we just did. Okay, they're going to be non-collinear, tail to head, find all the components, that kind of thing. All right. So you guys can start with those, and then I'll just come around and kind of check on you as you're working and see how everything is going. Okay, guys, just good point just kind of came up here, and this does happen sometimes. It's about what angle am I looking for at the end? Okay, so if we go back to this question here with the wildlife biologist tracking the polar bear, okay, we had that in this question, the biologist went south, and then they went back here northeast, and they ended up over here. Okay, the reason I wanted to find this angle here is because this is the one that points from where I started to where I ended. Okay, I want to make sure that I'm always finding an angle that points from beginning to end. Otherwise, if I find like this angle up here, that's telling them how to get back. Okay, it would be this many degrees, but it would be backwards. It would be in the opposite direction. Okay, so while the number might be the same, well, in this case it wouldn't be unless I found this one. Okay, but it's telling them how to get back. I always want to find the angle that points from where I started to where I finished. Okay, kind of the way I remember to do that is I circle my starting point, and then I find the arc that I create in there, and that's the angle that I want to find. All right, so something like that. Okay, in case that's been giving you trouble, okay, that's the angle that we always look for, is the one that faces from the starting point to the ending point. Any other ones that are coming up there that are giving us trouble? Okay, keep working then.